Hello and welcome to this instructional video on the IDMT curve calculator, which is among a suite of 10 tools that are designed to help a competent electrical engineer to determine the severity of an arc flash incident. My name is Mike Frayne and I'm the creator of the European Arc Guide and the author of the book The European Arc Flash Guide. To access the calculator, select the Calculators tab and then IDMT Relay. If you select Expand or Collapse, you'll be able to provide preset configurations and give you access to comprehensive guidance on how to use a calculator. The generic Inverse Definite Minimum Time, or IDMT, Time Current Curve Calculator will allow you not only to produce curves for the standard IEC and IEEE relay characteristics, but will also give a trip time for a given arcing current. Let's get straight to work and we can enter the arcing current, which we've worked out to be 5000 amps. In the next field, it's the pickup current, which is the value above which the relay will start to operate, and in this case we'll choose 400 amps. The remaining fields are all about the relay, and this starts with the curve type, and you can see here that both IEC and IEEE curves are represented. On modern relays, these are simply a range of settings, but older electromechanical relays were built to discrete standard curves. We'll choose an IEC very inverse curve. Next we have the current multiplier, and the range is from 0.5 to 2 in 0.05 intervals. We enter a value that corresponds with a relay setting. For instance, if the relay is a static, digital or numerical type of relay, then this can be obtained directly from the relay setting, sometimes via slider switches or digital readouts. For electromechanical relays, the detail can be obtained from the plug settings on the front of the relay, and this is described in detail in Chapter 8 of the guidebook on data collection. We'll pick a value of 1. The TMS field is a time multiplier setting, and we can choose from the drop-down list from between 0.05 and 1. Again, for static, digital and numerical types of relays, this can be obtained directly from the relay setting, and for electromechanical relays, this is obtained from the time dial on the front of the relay. This is described in further detail in Chapter 8 of the guidebook on data collection on electromechanical inverse definite minimum time relays. In this case, the value that we'll use is 0.25. The definite time field gives the ability to apply a definite minimum time for operation of the relay when the tick box is checked. Different relays give a different threshold for minimum time for operation, which, when stated, are usually at 10 to 40 times the pickup current as adjusted by the current multiplier. So, for instance, if the pickup current is 100 amps, the current multiplier is 2 and the definite time threshold is 20, then the curve will follow relay characteristics up to 4000 amps, which is 100 times 2 times 20, and above that threshold the time to trip will remain static, or in other words a definite minimum time for operation. Back to our calculator, and when we press the submit button, a time current curve for our settings is displayed here on the left and a second graph on the right, giving a full range of time multiplier settings which will be displayed for the relay data entered. Curves can be deselected by clicking on the associated colour block at the top of the graph. In addition, a time to trip based upon the arcing current will be displayed here. The arcing current can be changed to consider the minimum arcing current from the IEEE 1584 instant energy calculator and to take account of possible increased trip times. Finally, please don't forget the relay error and switchgear operating time. Fault clearance times are made up of relay reaction time plus trip coil delay time plus circuit breaker mechanism operating time as well. All relays have errors in timing which have to be declared if manufactured and tested in accordance with IEC 60255. We must also factor in the time for operation of the switchgear. This again can be obtained from manufacturer's data, commissioning, or preferably from timing tests, but as a guide for the purposes of arc flash calculation, a generic allowance can be built in. A table of allowances and generic switchgear operating times are given in Chapter 8, Data Collection. I really hope that you enjoy using the calculator in the field on your phone or tablet or PC, and that you'll find this and the guide to be a valuable resource to discover and manage dangerous levels of electrical instant energy in the workplace. Thank you.